My name is Lukas Weidmann, and I'm the CTO of Rego-Fix, and I'm responsible for the technology. And in this context, I would like to present you today the newest member of our PowRgrip equipment, which is the PGU 9900 Neo. First of all, it's important to mention that the basic PowRgrip technology is the cell. So we are still pressing our collets into the holders, and in the end, we have a really good clamping performance we can use on the CNC machine afterwards. So what we see here on the machine first, we have an included display, and the display is part of the new system where we have via the settings, for example, you can change language. We can also change some settings like responsible for the AI, which we'll see in a second. But let's first go directly into practice. I will perform now a basic pressing, and I have cleaned the collet and the holder, because what's important to tell here is if we talk about clamping, we have basically to distinguish between the geometrically based systems and forced or friction-based systems. So for example, clamping technologies like welding, for example, they are based on geometrically fixation. So this means that we use some kind of geometrical feature to clamp our tool. This means that we have really high forces to take the tool in position, but we have problems if we go to high performance in terms of minimal run out, for example. And in case we want to go to higher levels, let's talk about runouts around 3 micrometers, for example, we go usually to friction-based system. Friction-based system is, for example, also collet-based systems, but also shrink or hydraulic chucks, and PowRgrip as well. We'll try first the pressing. Now we press. This is really fast. We have about 10 seconds to press it in, and then we are ready. So what's new now is we have to wait a second. We see it on the small screen here, which at the moment is loading, but now we see that it's turned green, which means that we have an ultra press. Ultra press means that the system itself at the moment is possible or is able to detect if there are any kind of contamination on our collets and holders. And this is important because we have a friction-based systems, we have any kind of contamination on it, we have the problem that we can reduce or we can have reduction in performance. So what we see here is that it's perfectly cleaned, and it gives me the green sign, meaning that it's good. And meaning it is good is not only the run out, because this is something I could measure on a machine, but also the transmittable torque, which is something that I cannot measure at a machine. If it's not okay, then I will see it in the process, and then it's too late. So just to show you how it works, I will press out, and I have here some kind of tools that I can use to artificially contaminate or bring a contamination on the surface, and then we will see the difference. So this is now just a little bit of oil, cutting oil, which is normal what you can find on collets like this, because the machines like this, they are in the shop floor. So people are working with it. They do not have any gloves. It's just working daily business. And it's a high risk that they get any contamination, in this case, specifically oil on surfaces. And this is critical because, as you may know, that if you have oil on it, you reduce friction. And you reduce friction in a way that is bad for clamping, because it will be reduced. So now I have inserted it in the same way. And me as a user, I don't know, because at the moment that was for demo, of course. But now if I go to the machine and I press it, it's do the same as before. But now I will see in a second, the machine tells me that there is contamination found. And this is like a warning for me as a user, because I know now, oh, I have to clean it. And this is not meaning that the system is not working, but it means that we do not reach the 100% we want to go. For this demo, we think that about 10 to 20% of performance reduction is critical, and this is the reason when the machine tells you you should clean it again. Now I will do exactly what the machine told me. I will clean it. Now it's green again, and now it means that I can go on the machine. But this is the dashboard, which is just another possibility to get information from the device. The system is connected to the cloud where all the, let's say, the analysis is done. And also this analysis where we try to find contamination on the surfaces is done indirectly. So we use sensors included in the machine, which are then measured during the time of pressing. And this data then is analyzed in the cloud using some AI functionality to make a classification if we have contamination or if we do not have any contamination. And you will see that here as well, for example, we have different statistics. We have kind of an online live view on the system where we see what the system is doing. We also have a history. For example, here you can switch between different durations. For example, if I go to the last 180 days, and I see here, I have the blue line, which is the ultra press, which is 100%. And you see that the red line, which is kind of measurements where contamination was found, is decreasing, which means that there's some kind of learning found in the people working with this system, that they know this warning that can help them to make or to improve performance overall. We also see here this little hill, which could be, for example, if there's a new employee coming, which do not have the same standards, and you as a control unit, you see that, and you can fix it. And this is something which is not possible without this information. This is exactly where we want to focus on. We want to improve the quality by using the whole potential, the full efficiency of the system.